So I want to go over chapter 4, which are basically for statements or control statements. These are also called the loops. Now, you guys have already done the loops in your COP 1000, but the syntax for this Java is a little different than the Python. So we will go over a few examples and look at the way we write our loops, and then again, even with the loops, we will try to go back using the loops with our classes and objects. So that is something that we had done last time, where we talked about how we can define our classes, how we can define different kinds of attributes that go with it, and then the objects that you can define out of it, and how the objects can use the methods that you have defined in your classes and things like that. So we will bring again your if conditions and for or loops associated with those objects. So
if you have a chance, are you able to cover, or not cover, but like kind of go over the difference between a constructor and a method?
Absolutely. So the question was, can we go over our constructors? You say constructors? Mm-hmm. Okay. So before we start, let's do this. Let's go ahead and look at our constructors. And if we had done our Eclipse last time, so I think that project is saved. So let's go ahead and open that up. And we'll use the same examples that we played with last time so that we can go over this and clarify the questions. All right. So this was our class that we had defined earlier. So first of all, let's talk a little bit about constructors. What are constructors? Constructors are special methods that Java provides, and if you do not write a constructor, then Java provides you with one. Okay, that's what a constructor is. Number two is the constructor would always have the same name as the class. Okay, so here's an example that we wrote in last time, where we defined a class called computers. Now again, if you go back and think about what a class is a blueprint, okay? So, and then remember, in object-oriented programming, any entity can be defined as a class, okay? So we defined an entity called computers, and this particular entity called computer has some attributes that are associated with it. So what are these attributes? They're also in Java language called instance variables. So it probably needs to store some values. It probably needs to have some methods that let you do things. So those are the things that will go with that particular class here called computers. And these are all defined as private. So that's your access modifiers, and those attributes, you have to define them. And again, you can define them as private or you can define them as public. But the way you do things over here is you have a combination of private and public, which is also called information hiding. It's a good programming practice. And the reason you do it is because you do not want another group member of yours come in and change these values here. Anytime they have to reach this variable, they have to go through some public methods. Okay, so I define my three variables here: a string or two strings. One is a brand name, one is a color, one is a memory. Now I have not defined anything else, just these three variables or instance variables over here. And now I told you initially that if I did not have, if I would not write this thing explicitly, Java is going to provide me with one. Okay. In this case, I actually wrote two constructors. One of them is this one. As you can see, is the same name as the class. And also, I wrote another constructor. Again, why do I know it's a constructor? Because it's the same name as the class. And of course, these are nothing but special methods. And remember our method definition, it always would have your open close parenthesis. So this one has my open close parenthesis as well as this one. The only difference is one of them has parameters or arguments that you're passing, and the other one does not have anything. All right. So, and the concept is called overloading my computers, my constructors. So it's called overloading, where I have the class as the methods as the same name, but the signatures are different. When I say signatures, I'm talking about, is it going to take a parameter? If I can create another constructor called computers, but instead of passing 3, I can just pass 2 values. I can create another one which can only pass 1 value. So I can create as many constructors as I want. And the benefit of that is it gives me more versatility. So when I create my object, I can have different ways of creating and passing those values. All right? Yes. Question.
So even if the constructors are made the same way, if there are different categories to help pass through the data, it won't be recorrelating with other constructors?
It's not arbitrary.
Okay, say that question one more time.
Let's say if you have multiple constructors
Right.
with the same sort of conditions, if there are multiple applications to apply those conditions to, will there be no overlapping with the data?
Okay, so the question is, if we have the same constructors multiple times. Now, remember, I can write a constructor, and let me open this one, because I had kind of closed it out because I was trying to show why it is giving you an error. So here's a constructor. You see there's a signature difference. Let's write another constructor. And I'm going to say public. But remember, I cannot write it with the same signature like this. Now I can write it this is not allowed because it's the same signature. So when you create or use that to create or instantiate an object, the compiler says, hey, which one are you referring to? Now, it is absolutely okay to do this. Because why is it okay? Because it has a signature with 2 arguments. Yes, Carolina.
If I have 2 constructors, like with the same signature, but I just changed, for example, I just changed the string name, I changed the string size. Will be a string. So when I call this, like creating my object, the system will be confused because it will be string, like 2 constructors with the same kind of signature. Not
Good
the
question.
same signature, but the same kind.
Right. The question is, and we will create that just to see. So the question was, if I create another constructor called public computers, but this time I'm going to call it string, instead of name, I'm going to call it string size. And then if I pass that information, is that going to be confused? Now, remember, the thing that you got to remember is, look at the signature. I am saying this signature has 2 arguments. One is a string, one is an integer. I can also write something like this. where I do this. Only one. Now, her question is, right?
Yeah, I mean, if
Or let's say string
if I
new
use-
name.
If I use a string size and int memory value.
So you're saying string size
And int memory value.
Can't do it.
Okay. At this point, it's going to be confused because, again, what it's seeing is I have two signatures, which is the same type because it's saying it takes a string and it takes an integer. It takes a string, it takes an integer.
Okay.
So there it says, okay, now I'm confused. So I cannot do that. However, I can do 1, I can do 2, I can do none, or I can do 3. These are all okay. Okay. Now remember, these are just shells. I have to come in and assign. I'm going to say this dot memory value equals memory value. Right? Because what I'm saying is, when you call this particular constructor with one signature, the value that you're going to pass, let's say 25, 256, 512, that value gets assigned to this private integer called memory value. That's all I'm doing. When I call this one and I pass in the name and an integer value, then I have to come back and write a statement like this. Otherwise, it's not going to know what to do with it. Okay, so I have to come in and write something like this dot name equals name, and then this dot memory memory underscore value equals memory underscore value. So I have to write these statements here to make those values assigned to the object. Okay, so these are all different ways I can write my constructors. So I created one which is three arguments, created the second one which has 2 arguments, a string and an integer, created one which only has 1 argument, but see now it says, okay, I cannot do this one, so I have to get rid of this because this is the same as this. Correct? It's the same as this. Now, this over here, this is a variable name. Size or name is just a variable name. We are looking at the signature. So when I call or use that class to create an object, it is looking to see, am I going to pass a string and an integer value? If I can, then I'm okay. Okay, so I cannot do this one. This would be wrong, and I can just say because similar signature constructor created above, correct? All right. And then you have this. And then you have those set and get values. Now, look at what happens over here. How would I use, we have already used this one. How would I use this? Okay. So the way I'm going to use this is I'm going to come in, see how I had created these objects right here. I'm going to create another one. I'm going to say computers, new computer 1 equals new computer, but now I have to match the signature. And remember, one of my signature was a name and an integer. So I can always say Lenovo, comma 512, and this is okay, right? I can also create another one called 2, and if I go back and I used a name and an integer, only an integer. See how you have an integer? So I can say that is okay as well, because I created now with that signature, which would take only one argument. All right. And of course, once I create this object, I can associate that object with, well, remember, I don't need a set because I'm passing these values over here. So basically, I just need to be calling in all my gets, get color or get memory or get name. So I can then associate that new computer underscore 1 dot get name and get integer or get memory. Okay. Same thing over here, new underscore computer underscore 2 dot get memory, and it should bring me 1024. So these are how I'm using my constructors. Okay, now how do we differentiate between the methods? Methods could be anything. Now, as you can see over here, we are writing these methods called get brand name, but it could be any other. I can write another method over here, and I call it void. Let's say we call it message. I can write something like system.out.line. Thank you for using my class object program. All right. So at this point, I created another method called parting message. It's void, it's public, and I can now come over here and start writing something like this. So I can take this, and I can say new underscore computer underscore 2 dot message. So basically I associate this object with this message that I just wrote over here. You're good? Question here? None? All right. So messages could be anything. You just have to know what this means. This is going to be the name of the message. This one does not take any argument. It does not return any value. And it is a public method. And inside the body of the method, you can write anything. You can write one line. You can write multiple lines. But as long as you write a message, once you come over here, depending upon what you want to create over here, you know, the signatures that you use, you can use that object that you're creating over here, like this one or this one, and associate that with the methods. Not only this method, but also the other methods that you have written in the class. We good? Okay. So I'm going to move on to what we started with. And this is going to be our control structures. So the way we write our control structure in Java is with whiles, do whiles, and for loops. Now in COP 1000 or your Python class, you wrote something called for each. Okay, so it's similar but a little different in the syntax, but it does, or it works the same way. So anytime you want your program to repeat, that is where you have to select either a do or a while or a for. Just like your condition statements or decision statements like if or else if, you can have nested fors. So you can have one loop, inside you have another loop, inside you have another loop. So you can keep on nesting. You can even have two loops, one is nested within the other, and inside the second nesting, you can have a conditional statement like if. So you can write anything that you want. It's a matching and mixing all the constructs that you are given in Java to achieve the processing that you are trying to do. So it really depends upon what is the problem that you're trying to solve. And these are basically all your tools, your conditional statements, your if statements, your loops. These are basically given to you as tools. So we will look into the counter control iteration and also sentinel control iteration. And of course, these are all the algorithms and the pseudocode. So we'll take a look at that as well. And we'll look into this nesting if else and some issues there. So we'll see some of the examples there from which causes some of those things. Okay. Now, this is important. Before we even start writing, we have to identify what we are trying to solve, right? So the logic has to be very clear first. And the logic can be written in pseudocode, which are plain simple English-like statements. It can be represented by a flowchart, okay? And if you're using classes and object, it can also be represented by an UML diagram, unified modeling language diagram. And we discussed that a little, in our earlier class. So, and this is also important because all this time I was giving you assignments. I'm saying write a program or write a Java application which would add two numbers, or write a Java application that can do some math, make it interactive, ask the user if they want to do an addition, subtraction, multiplication, whatever the problem is. So I was giving you the problem. From here, I'm going to start switching a little bit. I'm saying, okay, now you know where to use a condition. Now you know how you want to repeat something. If you want the program to be doing, more than once, I can write a loop. Now you have to apply that to a problem. So think about anything that you guys do in real life and say, okay, can I write an application which is going to solve that problem? So you have to identify the problem, use the concepts that we have discussed, and write a solution to it. With me? So I want you to start being a little creative. I am not going to give you the problem. You identify the problem and you write a solution. Now, in the process, if you need help, I'm always there. So we already talked about the algorithms. There's no problem here. Pseudocode I just described. And the sequential action, again, this is going to come when I start showing some of the programs as examples. So here is an example of a sequence where it said, if I start my program over here, I would add grade to the total and add 1 to the counter. So the problem here is, basically what they're trying to show you is, let's say you are given, you identify a problem where you're trying to write a Java application to add multiple classes, okay, to calculate the grade of a person. So let's say you have one class and you have multiple exams, quizzes and exams and discussion, whatever it is. How would you go about doing it? The way you do it is you would start off with your grade, let's say at 0. And then every time you take an exam, you're going to take the grade that you received. So you got an 80. You're going to add it to your total. So initially your total is 0. You add 80. Okay. Then you also add 1 to the exam counter. And then you say, okay, go to the next one. I'm going to add, I got a 70 next time. So my total becomes 80 plus 70. But my exam counter now becomes 2. So the number of times I take an exam, I'm going to add it to the total and add it to the counter. All right. So this is how I have to calculate multiple scores from one class. And then you can start, adding more. I said, okay, now this particular class has 2 exams. But then let's say you're taking another class, this is a database class. In that class, you have 4 exams. Let's say you go to another class and said, okay, this is an English class. In English class, you have 5 exams. So each class is going to be different, but you can use similar approach to calculate your grade from each class. Yes? So that's the logic that you're going to use. Okay? So, and this just talks about the symbols and like what these things means. This is the start, this is the end. You see that there's a difference. One is with circle, one with a circle, and another outside ring here. And then these are the processes, and they talk about the decision symbols. This one does not have any. Right now, we're just going to the sequence. Let me see if I can show you. All right, so here you have a decision symbol here. So I said, okay, if the student grade is greater than or equal 60, then I'll say pass. So this is a single point. If it is greater than or equal 60, it is pass. Of course, the else, the other condition is less than 60, then you're failed, right? So this is basically the flow chart. Again, starting my program, there's my decision point, my diamond. So one option is passing, the other option is ending the program. And again, Over here, in this case, you do not have a statement, but you can always include a statement. In this situation, it is either you're saying passing or you're ending the program. Okay? So this is where now I add this. So previously it was either you pass or you end the program. This time you said, okay, if I get over 60, I pass, otherwise I fail. Right? These are the simple stuff. I'm going to keep moving. So this is the one that changed from what we were showing last time. So now it is greater than pass, less than fail. Now you can also have a situation like this where you have multiple conditions. In that case, you can write your else or if, else if, and you can continue. So in this case, you're saying greater than 90, greater than 80, greater than 70, greater than 60, and then you are at the very end. So if is more than 90, A, else, which means it is not more than 90, then you catch this sequence and print B. Again, else, which means it's not 90, not 80, is it more than 70? Yes, print C. Else, so not even more than 70, else 60, okay, print D, and anything below that, you're going to print F. Simple stuff. Question here? Take a look and tell me if you understand the code here. Yes?
Pretty simple.
Pretty simple. Now, a few things to point out. You see how you write your if statement? This is your condition, right? This is your condition. You do not put a semicolon here. I've seen this happen all the time with students because remember, in Java we say at the end of every line we put a semicolon. Semicolon means at the end of the line. In this case, this is a condition that you are comparing. What happens if this condition is true? Then we get into this body which is starting with a curly bracket ending over here. In this case, you only have one statement. Okay? You can have multiple statements. In this case, in that case, you're going to call it a compound statement. So you're going to say system out print line A and then come back and write another system out print line saying you have done an excellent job. So now two statements. And everything needs to be enclosed within that curly bracket because if that top condition happens to be true, then you execute both. That's what it's telling me. Okay.
And so this is an example of like nesting right here.
That's an example of yes.
Because like so each if statement has to be within that else.
Okay.
Like under you know what I'm saying? The like 80, 70, 60. And then
Well, it could also be a nest where you say if student grade is more than 90 and then write another one saying if the condition is, so you can have an if, another if nested within. These are just multiple conditions that you're checking. Okay, so you cannot probably call it completely nesting. And nesting is you have an if and then inside that if you have another condition. So let's say you write a program where you're saying, let's say you are above a certain age. Okay, if that is true, then you say, let's say if you earn more than this much money. And then you have another condition saying, okay, let's say if you are married or single. Okay, depending on that, I'm going to give you a tax rate. So that's a nested condition. So I start off with certain age, do you make a certain amount of money, and then are you single or married? In that case, I said, okay, I'm going to do this. Now, remember the very outermost loop that is checking for that age. once that condition is true, then you're checking two other conditions. If that first condition does not meet, I cannot even go inside. But there could be a situation where you meet the first condition, you meet the second condition, but you don't meet the third condition. In that point, you go from the first to the second, and then you come out. You cannot go to the second one. And we'll talk about more about the nested loops. Okay. Again, the analogy that I give is when you have nested things, it's like opening a door. You have a door outside, you have another lock inside, you have another lock inside. So you open the first door because you have a key, you go in, do whatever you need to do there. At that point, you check and see if you have the key to the next one. If you don't, you come out. You finish your business, you come out. You can't even go inside the next one. But if you do, you go to the next one. Do your business again. But when you come out, you have to check out one step at a time. So you come from the second to the first, and then you come out. Okay? All right. Let me ask you this simple question here. You see this over here? Can I reverse the logic, which means, can I say if student grade is less than or greater than equals 60, I get a D. If the student grade is greater than equals 70, then I get a C. If the student grade is greater than equals 80, I get a B. Else if I got an A, else I did not, I failed. Can I do that?
In that order?
Yeah.
No.
Can I flip the order?
Oh, yeah.
Can I? Okay.
Why not?
All right. So let's say I put in the very first thing. I say if student grade greater than equals 60, then I say system out print line D. Then I say else if student grade greater than equals 70, system out print line C. Can I do that? Yes? No? Okay, tell me why yes and why no.
The way I see it,
Because there would still be a range of numbers to choose from that are above 60.
Okay.
But it's not
Yeah.
supposed to be limited to.
Very good, very good. So logically you can, because if you write the right syntax, is it more than 60? Yes. More than 70? Yes. But your output is going to be wrong. So let's say somebody gets 85. Then the output is going to be, you got a D, a C, and a B. Because 85 would meet this situation, and this situation.
so you could fix that by instead of having greater or equal to, you could have in between.
Yes. Of course, I can say this or this or this and this, or I can give it a range. Absolutely. Yes, yes. I mean, but initially my question was syntactically, it is okay to reverse this thing, but logically, if you think about it, if I put greater than 60, if that's the condition I check, if I get 95, then I meet my D. I meet my C, I meet my B, and then I also meet my F. So my grade is going to be D, C, B, and A. But that's not what you want. What you want is you want to start selecting things out. Now, you will see also that there is something we will start writing with the switch statement, which is a break. Basically, it breaks out. As soon as you meet the situation, it doesn't need to go through the entire loop. Okay? All right, moving on. All right, so this is where you are talking about the blocks. Remember how I said, if you write single statements like this, system out print line, Java would allow you to take out these curly brackets because it's only one line, and the compiler knows anytime you write a condition, the line following that is the one that is associated with it. But if you want to have more than one line to follow that condition, you always have to put that within a block. But it is always a good practice to keep your block within the curly bracket. I personally always do that. It tells me in my mind, okay, if this condition is true, even if it is one line, this is what gets executed. If the second condition is true, even if it is one line, this gets executed, okay? And of course, you can also have a combination where this is like this. So passed, but this one failed, but you want to write a second sentence again. These two lines are now included within the body of that else. So if this condition fails, if it is not true, you catch your else and both of these lines get printed. Good? All right, moving on. So we already talked about this. Okay, Boolean expression, basically, true or false. You can also write a statement like this. Java allows you to write something like this. It says system out print line, but then the entire condition is written within the parameter. So it says student grade greater than equals 60 question mark. So this is my condition. All right. If the condition is true, the very first argument gets executed. If the condition is false, the last argument gets executed. So Java allows that. So if you say, okay, I like the style and this is how I'm going to do it, that's fine. You can write it. Or you can always go back to the other one, saying that if. Okay. Again, when you see something like this, remember one thing I always try to emphasize. I do not want you to memorize this. Okay. If you forget, it's absolutely okay. You can go back and refer to your book and look how it is written. But I want you to understand what this is doing. So this one is my condition separated by a question mark. If this is true, this one gets executed. If this is false, this one gets executed. Again, these two arguments are separated by a colon. But again, do you want to always, I forget all the time. So I go back and say, let me look to see how I can write this. And of course, the reference is there, the library is there. Okay. So these are things that are always available to you. Just make sure that you understand. It's important that you understand how you're writing these programs. So that's why I also take a lot of time to go through these individual programs that are written in the book. And I always recommend program like this, type it out, type it. You will make mistakes, but you know how to fix it. So let's go through this thing quickly. First of all, this is a application which is writing only the class, correct? It does not have a main method, which means you can compile this code, but you cannot run it. Why? Because as soon as you hit your run, the run compiler always looks for the main method to start. If you don't have a main method, you said, I can't do anything because I cannot find the main method. So this program can be compiled but not run. Okay. So let's see what it's doing. Public class student 4 and 5. Do we have any question there? You have seen this before. Defining two instance variables. One is a string, one is a double. And both of them are private, right? All right. What is this? Go ahead.
How come they're private again?
How come they're private? Because you do not want people to come in and change or put in a value here. If you want to add a name for a student, if I create an object called Nicole, okay, that name has to be reached by some public methods. Okay. All right. What is this? Line number 8.
Oh, that's a constructor.
It is a constructor. How do we know? same name as the class. But look at the signature. What does it take? 2 arguments. One is a string, one is a double. Okay. What do I do with it? For the first argument, which is the string, when I call student, new student, and pass in Abraham, so that name gets stored in this name, which is this private variable. Correct? Now, for the average, I'm doing a little statement here. What am I saying? I'm saying if my average is greater than 0, I go inside my curly bracket and I write another if. Now, this is an example of a nested if. So I'm saying now if the average is less than equals 100. So just like you suggested, I can avoid this thing by giving a range. I can say if average greater than equals 0 or average less than and average less than equals 100. Then I'm good, because you cannot calculate an average if it is more than 100, right? You have to break it down to 100. So this is my range. So I say, okay, if the average is above 0 and less than 100, then that average gets assigned to this average variable. And again, why are we doing this? Because remember, this is my blueprint. I'm going to create 24 different students. They would all have their different names. They would all have their different averages. But I don't want to get confused. I don't have to create 24 of these things. I create one, and then I just instantiate my object. Student 1, student 2, student 3, student 4. Student 1 is Nicole, student 2 is Avram, student 3 is James, student 4 is Carolina, student 4 is Eden. So that's how I create my thing. Now, I will also see when you come to the arrays, if I want to do 24 of those things, I can write student 1 equals this, but I can also write an array. Or I can write a loop. I said, okay, starting with 1, ending with 24, create all these new objects. So I can use my construct in any possible way that I want. It's important again to understand the concept. Don't worry about the syntax. Do you understand the logic? And can you make it, do you understand how the programs, the lines, the codes that you're writing? Syntax, yeah, you miss a comma here, miss a semicolon here, you do not call the right name, you misspell your method name, you can go back and fix, as long as you understand what you're doing. All right, so any question for this particular constructor? You're good? Okay, now, can I not create another student with just one argument? Absolutely. Okay. I can also create another one with one argument, but this time it's going to be a double. So don't get confusing. Okay, this one, the other one only took one argument, but it was a string. But I can create another one with an argument, just one, but it's a double. So now I have 2 separate signatures. I can also create another one with one argument, but it's an integer. Still okay. All right. So the data type is the one that would make the difference. All right. Let's go to the second part of it. So now I'm creating my set names and get names. And again, if you use NetBeans or Eclipse, that can automatically be generated by them. So that can automatically be generated by them. And of course, if you want, you can write them as well. So, all right. Now, just like my previous one, when I write my set average method, look at what I'm doing. Public void, it doesn't return anything. This is the name of the method. And I call it double student average. So I'm basically passing a value. and then the value that I'm passing, I'm checking to make sure that it's within a range. So you cannot pass 205, or you cannot pass a -5, 50%. So that's my check, all right? So if I want to use this value called, use this method called set average, I have to pass in a double integer, but that integer is going to check for the range. If it doesn't fit the range, it's not going to assign it. Okay. Now, over here, this is my set average, this is my get average. So get average, again, it says double. So that's why I always have a return statement. Now that is another indicator I tell you, read the method get, which means you're trying to get something. And then you also see this over here. So it's public, and it says it's going to return some kind of a value. What kind of value is it going to return? Double. So inside the body of the method, you can do a lot of processing here. This one just one line, but it can be 5 lines. But at the very end, you have to return something. Otherwise, it's going to complain saying, hey, you say you're going to return a double. Where is my return? So you have to write that return at the end somewhere. Because otherwise, when you call it, it doesn't know what to do with it. All right. So it explains the program, which we had already done. All right. So now they write another program. Again, in Java, everything has to be a new class, but in this class, you're going to create objects. Okay, so my first line, public class student test, that's the very standard way of writing it. Anytime you write a class, you have to write another class, which is a test class. This is how you test it. Main method, now it tells you can compile and also run, right? Student, name of my class that I define. Name of my object. This is how we do it, instantiation. So new, name of the class, and now I follow a signature. A string and a double value. A string and a double value. So account 1, account 2, account 3, account 24, same thing. Just call it, pass these two values, and it sets it. Okay? And then I write a system out print line. Remember, this is a printf. So placeholder. First of all, it's looking for a string. So if I say Jane Green, so Jane Green's letter grade is %s %n. And then it says account1 dot get name, comma, account1 dot letter grade. So get name is going to come in over here, and then account1 dot get grade is going to come over here. So it's an A or a B or a C. That's why you have a string there. Same thing. Get name, get letter grade. Good. All right. So Jane Green's letter grade is A, or John Doe's is C. Again, all given by the signature and the way you create an instantiated object, account 1 and account 2. Now, as I was telling you earlier, or the examples that I was giving you, can you not write more constructors? You can write one which is blank, and then you can create an object and ask for that question. Please input your grade. Take that value, store it. So now if I say, okay, make sure that you see how this is all have to be written out. So sometimes we call it, these are hard coded. So you have to know everybody's name, but you do not. So you can make it a little more interactive. You said, okay, blank. Okay, please input your first student's name, Nicole. Take that value, store it in. Please student for Nicole's average. Take that value, put it in. So now I can make the program a little more versatile, more interactive. Okay. All right. Continuing on. All right. So this one is This one is just basically showing you if you write a while statement like this at one point, the value becomes, false. So when you keep on saying less than equals 100, 3 times product. So at one point, that 253 is not more than less than 100 anymore. And we'll show you some examples where you will see that it can become an infinite loop. So let's continue on. Okay. So this was the example that it was showing earlier. So you start your program, that's a decision point, and that you have another decision point here because the result that you're getting, you're basically multiplying that by 3. But at some point, the product becomes more than 100 because you multiply that by 3 at one point, it becomes more than that. All right, so continue on. Let's take a look at this one, okay? Now, this is written as one Java application. It is not written as a class and an object, right?
Mm-hmm.
So let's take a look. Public class average, so that's the name of my class. I have a main method. I have a scanner because I want to have the user input it. So scanner input equals new scanner system.in. Now, I define a total. Initially, I start up with a 0. I also define a grade counter. And I started at 1. Again, it's up to me. I can start it at 2, I can start it at 0, I can start it at 5. Okay. Now let's take a look at the loop. So we are setting everything up when I say, okay, what happens if I want to repeat the same calculation over and over again? Okay, so now I say while grade counter, remember 1. So I replace the grade counter with the value of 1. While 1 less than equals 10, system out print line enter grade. So it's going to ask you the question. The user inputs the grade, stored in grade input. Remember, that's my object input dot next int. Another method, right? Nothing here. Now, then you go to your total. Remember, your total had 0. So you input 70. So 0 plus 70. And then it says, go to the grade counter. Grade counter equals grade counter plus 1. So it started with 1. Then it's 2. Right? Now, you see how it is all included within the block, which means when it comes to line number 19, it cannot go to line number 20 or 21. It has to go back and check the condition. Remember, my grade counter is now 2. So now the value is 2. Is 2 less than equals 10? Yes. Same question again. Same way you can take the grade. Same way you can add the total. So first time you got a 70, next time you got an 80, and then you add to your 80, and then grade counter equals 1. So it will take up to how many grades? 10, right? It says less than or equal to 10. So you can calculate up to 10 grades, add everything up, and store it in your total. Now, can you associate that with an object? Absolutely. You can write this method called grade class average, and then go and ask the object. You can assign a name. So in that case, you're creating, remember that versatility of the object that we were talking about? I said, okay, I want to assign an object, and I would just have a blank constructor. You ask, what is the name of your first student? Say Nicole. And then you say, for Nicole, calculate average. Right? You can even make the question and then ask saying, how many test do you want to calculate? And somebody says 5, which means my grade counter then changes to 5. So then I can assign, I can take that as a variable, store it in my grade counter or in a grade count. I store that, the value in grade counter, and then my condition becomes y, my grade counter less than equals that value. Right? You can go to the next object, say, okay, define a name, Carolina. You assign that name and they say, okay, how many exams do you calculate? And you said 4. Again, store that variable. Same thing, right, with 4. So hers is with 5, yours is with 4, Abram's is at 6, his is with 10, his is with 30. I can go individually. The more granular I make, I can use it for any purpose. All right.
So you could have an input to where the user could set how many times it repeats.
Sure. Why not? Same, you see how you have your scanner input, and if you say integer number of exam, let's say you define a variable,
Right.
int number of exam, and then you ask that question, system out print line, how many exams do you want to calculate? And says, you put into the input dot next int, store it in number of exam. So then you're going to say y grade counter less than equals number of exam, and then you run the same thing. Right? You ask the question again for another object. How many 4? Okay, same thing. Take the value, store it, and then the grade counter basically checks to see equals the number of exam. So for individual objects, I can change my exams. So this is an example over here. In this case, remember, we went with less than equals 10. So of course, as you can see, it asks this question 67 at 10 times. All your grades, total of all 10 grades is 846. Class average is 84. Why is it 84? Is it not 84.6?
It doesn't have the 0.1f or 0.2f at the end of it.
No, it is because we have stated as an integer. Remember, with an integer, I discard that value. Is it correct? You can, depends upon who you ask. The student says 88.9. I want my 0.9, right? So yeah. So my question, the concept is you got to be careful about the data that you're trying to calculate. Okay. All right. Local variables. These are basically what you're defined saying as, sometimes within a program you can define something like, for example, when you have an int grade, this is local within this while statement. Okay. So this grade is only going to be seen inside here. Okay. Whereas this one is kind of global because it's total and grade counter. So that's between local and global. We will talk more about these things, and I'm going to keep pointing these things out as we see our programs. Okay. Okay. I think this is not so important. They also talk about the secure coding. So it is always good, it is considered a good practice to ensure before you perform arithmetic calculation that you will not overflow. And again, there are, if you go to this site, they tell you certain things that you can do. And these are basically secure way of calling things. So I'm saying integer, anytime you're receiving any input from the user, various problems might occur. For example, in the following statement, we assume that the user will enter an integer grade 0 to 100. But you never know, right? I can include 204. What's going to stop me? So if I want to stop that, however, a person entering get could enter an integer less than 0 or greater than 100. So an integer outside the range of values that cannot be stored in an invariable, a number containing a decimal point or value containing a. So remember how we were saying the if condition during an average? I can write a little, statement, or we can also do something which is the simpler fix. Whenever you define something like this, when you ask this question to the user, input your grade, write detail. The grade should be between 0 and 100. That's a, telling user, okay, make sure you input a now. You can put a way of programming where you say anything more than this, I'm not going to take the value and give you a statement back saying you input a wrong value, or you can just leave it up to them thinking, okay, he's going to or she's going to do the right thing. But if you leave it for that person, your program at the end might give you wrong values because there's no checks. So we will talk about later on how you can write some try-catch values. So you try that statement. If it does not meet the range, it will come back and throw out an exception saying, sorry, your value that you're entering is wrong. So how do you stop a person? You say, input a grade in numbers between 0 and 100. And Abraham says, I'm going to put in my name, Abraham. It's going to break the program, right? So you can write different ways to stop those program breaking. All right, so this is basically to validate a range. Okay, let's take a look at the Sentinel controlled program. And initialize variable. Again, these are things that you need to go over because you're going to be asked questions in the quizzes. I just want to make sure. This is also an example of a pseudocode. Remember I was telling you about writing simple statements, but if you look at this, this is written in a logical order. Sometimes it really helps if you try to break this thing down like this. Look at this. Initialize total to 0, initialize counter to 0. Prompt the user to enter the first grade. Now, you cannot switch it. You cannot say prompt the user to enter the first grade and then say initialize to 0. Because then what happens is if the user inputs 100 and you initialize to 0, that 100 value becomes 0 at that point. So that's why the sequence, the logic order is important. So input the possible, so press for the first grade, input the first grade, possibly the Sentinel. So Sentinel is basically a way of telling the program that check for this value. So it sometimes could be a -0 or a -1. It says enter your first grade or -1 to stop. So that's your Sentinel value. So you're checking to make sure that the value that you're inputting is either the first grade or is -1, which means the user does not want to input any grade. So that's what it's catching. And then it says, then your condition becomes while the user has not entered the Sentinel. So while the input is not equal Sentinel, it's not a -1, I can then start calculating. Now you can always come back and say, what happens if somebody inputs 504? Then again, you have to come back and check. The grade should be between 1 and 100, and also -1, to quit. So this is my condition. Add this grade to the running total, add 1 to the grade counter, prompt the user to input the next grade, and then input the next grade. So if the counter is not equal to 0, set the average to a total divided by the counter, print the average. Because remember, you're asking, if you're trying to do an average, you have to say how many. So if you say 3, then your condition is okay, you're going to prompt it 3 times. At that point, you're going to come out and divide this. Okay. Okay, so continuing on. All right, let's take a look at some programs over here. So the same program, but look what they have done now. I'm writing it with a Sentinel. So any question here? Should be pretty simple. My class average, main string, created my scanner, and these are two of my variables that I define or initialize at 0. Okay. Next one, I end my statement here, enter grade or -1 to quit. And then you take that value, store it in this grade variable. Now, I write a while statement and I say, while the grade is not equals 1, right? Total equals total plus grade. So remember, my first time my total was initialized at 0, so whatever I input here adds to the total, and then I increment my grade counter, right? And then I ask the question again, enter grade or -1 to quit. And you take that value and store it in your grade again. But you're not done, because you have to come and check with your grade, because this is within a loop called while. So while the condition is true, so what is my condition? Grade not equal 1. That's also called the Sentinel value. So while this is not equals 1, again, I'm going to go back and check. All right. So I will continue doing it unless I get a -1. All right. And then I said, okay, if grade counter not equals 0, then I'm going to say double average equals double total, the one that we calculated from there, divide that by grade counter, and then total of all grades entered. Again, %n goes to the next line. Total of the grades entered is %d, an integer, %n. Next line, grade counter, comma, total, which means 4 exams, comma, this is the total. Else, no grades were entered. Okay. So here is the output here. I'm going to ask to enter a grade or -1. So 97, 88, 72. And at this point, the user says, I don't have any more grades to input, -1. So it says total of 3 grades entered is 257. And the class average is 85.67. Because remember, my condition for the class average was it is not 0. So I got 3 exams. I divide that by the grade counter. So this is how I calculate my average. All right, continuing on. The reason I'm going so fast through this is because I've already mentioned these things. Omitting the braces that delimit a block can lead to logic errors. Remember, I was telling you everything needs to be within those curly brackets. So that's what he's referring to here. All right. Floating point numbers. Remember the difference between a double and a float. One, I think double takes more space, float takes less space. However, double can store bigger decimal values, float can store less. Depending upon your program use, you're going to choose the right variable or right data variable. All right, let's continue on. This is another one, which is the pseudocode here. And let's take a quick look at this program. So here I have a scanner, and then I call a class called analysis, and I have a public static void main method. I create a scanner object called input, and then I define some variables here: passes, failures, and student count. Okay. And then I say while my student counter is less than 10, which means I can only count it for 10 students, right? System out print line, enter result, 1 to pass, 2 to fail. So basically these are codes that I'm assigning. So you have to say 1, go to the next student, 1 if it passes. And of course, if the student fails, then you're going to hit our input of 2. And then those values, 1 or 2, are then going to be stored in this integer result. Now this is within the while statement, right? And then it says if result equals 1, I'm going to add 1 to the pass counter. So in the beginning, I have defined my passes as 0, failures at 0. Okay. So within my while statement, I'm asking for them if it enters 1. So I go into this because remember, I'm going to sequentially follow or execute the program. So I check for this condition. It is less than 10. Then I ask user to input this. You take the value, then you check to see if the value that you just inputted in result is equal to 1 or not. If it is, I'm going to add to the pass counter. Else, it is not a 1, which is a 2, then I'm going to add to the fail counter. Okay, and then I'm going to add 1 to the student counter because this student counter at one point needs to be false. If it is not, it becomes an infinite loop. So if you happen to miss out on this 30, line number 30, then it's going to keep on going and asking the same question. Keep on going and asking the same question because at no point this becomes less than 10. Because remember, your student counter you initially started with 1. So unless you add that 1 to the student counter, it always is going to be 1 less than 10, yes. 1 less than 10, yes. So you should keep on going through and asking the same question. So I input all these things and I can count the number of passes that I have and I can count the number of fails that I have. So this is my program over here. Good? Okay. You can also see some assignment operators. You can also see something like C plus equals 3. It's nothing but C equals C plus 3. Just showing you little, Java things. So when you see something like C plus equals 3, this plus equal means you're going to take the variable and then add that value to it. So this is again your assignment operator. Plus equals, you can write C plus equals 7 equals C plus 7. When you say minus equals, D minus equals 4. So this is the operator, this is how it's used, and this is what it means. With me? So multiply equals, you take the variable, multiply that by 5. Divide equals, which means F equals F divided by 3. I personally always write it this way. I always say C equals C plus 3. It makes it easy for me. I don't want to, sometimes use some of those plus equals, minus equals. I can, but just for my own clarity, I use this. And you can do it either way. All right. If you are adding or subtracting, Java also allows you to do something like this, plus plus. So prefix increment. So you can say plus plus A, or you can have A plus plus. There are difference between this. In this one, it increments by 1 and then use the new value of A in the expression which resides. Over here, it actually takes the current value of 1 and then increment by 1. So pre and post. Okay, same thing. Decrement, which means going down. Now remember, these plus plus that we say is by 1. You can also do plus 5 or plus 3. You can also increment by 5, increment by 3. There's no problem with going more than 1. Okay, you might see these things being used, so that's why they give you all these examples. So this one basically shows you the difference between a pre and a post. So when you have something like a post, so you assign a value C, a 5, system out print line. So before we do any plus plus, pre or post, if I do a system out, it's going to print 5 because you assign the value 5. Then you say post incrementing C++ it still prints 5 at this point. The next time it's going to print 6. However, in this case, again, you start off with a C equals 5, and the first time you're just printing what you have stored here. But look what happens over here. System out pre-incrementing. So plus plus C. So you add 1 to 5 and it prints 6. And then you say system out print F. Only the C at this point, it is now changed from 5 to 6. So that's why it says 6. Right? All right, so that's good. That's good. And then you have all these other operators, plus, plus, minus, minus, less than equals, not equals, different kinds of operators here. All right, this is where I'm going to stop. We're going to take a break, come back and write some program. Now, what is this? This is the GUI part of Java. They use this library called JavaFX. In this chapter, this is pretty simple because you use something called a scene builder. So if I continue on, you will see that with your scene builder, you can create an output or an interface like this. So basically, when you click on draw lines, it's going to draw a line over here. Okay. Now, it also tells you that you can draw lines, and in this case, it does not draw automatically. There are a lot of codes that go behind this. But the code basically allows you, when you click on it, this is what the output is. But again, this is not an automatic. There's a lot of code that goes behind it. Okay. And we do it using another plugin called Scene Builder. You have to download your Scene Builder, and then you're going to write your code, and then you can create a GUI application. Now, this is the part that I told you earlier that I would not do it because I found out that Scene Builder is very, very finicky. It does not want to work with certain versions of NetBeans or Eclipse. Okay. This is just one of the Java GUI library. There are other libraries in Java as well. Swing is a little easier. For that, you do not have to download any libraries, download any plugins as such. You just import something. But it's just telling you that, when you use a GUI environment like this, the screen that you lay out is broken out into something like this. You have a top section, left, right, and a bottom, and then you have a center in the middle. So you can actually input these individual elements on the top here or right here or left here. So if you say whatever that button is, if you call it button B, and if you say button B on top, then this is where it gets placed. If you say button B on center, this is the section that it gets placed. Or the bottom, this is where it gets placed. Okay. So continuing on, you can do something like this where, again, a lot of programming behind this. So all these little arrows that you see is going to open it up, and these paddings. So you click on this, it's going to give you some list, a lot of programming behind this. So as you can see over here, these are the kind of things. So you start importing with something called an action event, fxml, you bring on the scene, you bring on a canvas, and then you start writing your program. So that draw lines controller, that's the one with that 2 arrows. This is how it is done. So you define a class, and I'm not going into details. You define a class called draw lines controller. You have to bring in this fxml private canvas. It's an object. Again, it's a private object. Then you write a method called draw lines button pressed. Okay, this is a method. This method passes an action event. Okay, again, this is the object. Remember how you said string name? So action event is an object, and this is the name of that variable called event. Okay, and it says I am going to create a new canvas, but the way I do it, I said graphics context, this is again an object that is defined in one of these libraries that you imported. You can create an object name called GC, then associate that canvas dot another method called get graphics context 2D, and these method names are specific. You have to be written just like that. If you miss the graphics with a small g, it's not going to work, because it is a method that is coming from one of these import libraries. So you call this method called 2D, and there's no parenthesis, there's no argument. And then you take the same GC object and call another method called stroke line, and these are the parameters. So you start with 0, 0, so coordinates. Start with 0, 0, and then it goes all the way across. That's why you said canvas.getWidth, comma, canvas.getHeight. So it goes from one corner all the way to the other. Same thing over here. Another stroke line, canvas, getWidth, getHeight, again starts with 0, 0. So that's how, and it shows you when you say that x, y, 0, 0. So this point is your 0, 0. It's not like your regular coordinate. In Java, these coordinates are at the top corner over here. So if you want to go positive x, you go to the right. If you want to go positive y, you come over here. Okay, so if you say 0, if you, let's say you say 3 and 4, so it's going to be somewhere around here, and 4 is going to be somewhere around here. Okay, so that's how you actually give those coordinates. All right. All right, so these are more codes that goes with it, and you can define, and in this one, they did something like this. Draw a line, again, they kind of draw the line which looks like this. So you can keep on doing different kinds of design. Again, a lot of codes that goes behind this, and that's your GUI environment. Yeah. Let me go ahead and stop this here.